afternoon, Rubyfuza. Oh, come on. Guys, we're in Cape Town. Good afternoon, Rubyfuza. That's more like it. Finally, I thought everyone was busy dying over there. So, Christmas Day 2016. Okay, it was pretty cold for me, but for you guys down here at least, I hope it was good. We had a new release of Ruby, which is pretty standard. It's our Christmas treat every year. So, given that it's now just over a month after that, let's go and unwrap some of these presents that Matt's elves have put together for us. So, just by way of introduction, thanks, Lance. I'm McKelvin. I work for Resource Guru. You would have seen we're sponsoring around here. If you want to chat about that, please come speak to me. Okay, so the next 20 or so minutes, we're going to look at what's been changed or added or modified in Ruby 2.4. So the first up, the unified integer class, or also known as the reason for the deprecation warnings you're all seeing in Ruby 2.4. Binding.irb, if you've been working with Pry at all, you'll like that. Float.round, which was probably the thing that came closest to causing another Ruby drama. Turbo hashes, or hashes got a bit faster. Array min, array max improvements, and regex.match just speeding up our performance. Ruby 2.4 is quite an exciting release, so if you're not using it in production yet, please do. By way of hands, who is using 2.4 in production so far? Guys. Please, if I had a sad trombone, I would. Okay, so let's chat about the unified integer class first. So, the old way. Two types to store integer values in Ruby. If I don't kick the wire. If I don't kick the wire, that would be helpful. Okay. Two classes for storing integers. You have a fixed num, which stores as a long on most systems, depending on whether you're on a 32 or 64-bit operating system. And you've got big number for anything that doesn't fit inside a fixed num, really. What the ranges for fixed num are varies depending on your operating system and CPU architectures. So what happened there was when Ruby being written in C needed to migrate to have 64-bit data structures. We have a variation, or some varying sizes depending on what operating system and architecture you're using. Most of the time, if you're working on Unix, Linux, you're going to have LP64, which means if you're on a 64-bit machine, you're going to have a 64-bit long. And that therefore is what Ruby is going to be using. What that means is that we get signed integers in fixed nums have a range of values that we can use. You have a negative minimum, positive maximum, and depending on whether you're in 32-bit or 64-bit C Ruby, you'll get a certain min-max, and JRuby, because it's running on the JVM, has its own size. You'll notice, by the way, that we don't get the full 64 bits because 1 bit is your sign, and Ruby reserves the other bit to mark that it is actually a fixed num as opposed to a big num in C Ruby. So what we have now is one integer class to rule them all. The difference between fixed num and big num, the Ruby developers decided that needs to be abstracted away. It's an implementation detail. And that can lead to some interesting nuances if you're not aware of it. So by having a single integer class, we now have more consistent types and hopefully a bit less controversy around that. And I'm going to take a quick demo just because monkey patching. So, the noise. Okay, so can everyone hear me? Okay. I saw some nods at the back, so I'm assuming that's all right. Okay, the first thing I want to just look at is adding numbers. So I've got a script here that's going to just take x at the size of 40 bits, 2 to the power of 40, add 1 to it, 10 million times, just going to get a size of that, and the same thing with a value y, which is an 80-bit, which would fit into a big num in Ruby 2.3, but would be an integer in Ruby 2.4. So what I've got here is I've got two shells parallel. So if I run ruby-v, the left side is running Ruby 2.3, right side is running Ruby 2.4. If I run, what is it, add nums rb, you'll see on the left side, the class name of 2 to the power of 40 is fixed num. On the right side, you'll see in both cases it's integer. The performance characteristics is more or less the same, but all that means is that the actual implementation of switching between a fixed num and a big num is now abstracted, which has a bit of an implication when you're doing some perhaps monkey patching or metaprogramming. So if I look at this guy, where I've defined a method fuzify, because we're at Fuza, on fixed num. If I run this in 2.3.1, this would, let me just run this. What is that file? Fixed num. So in Ruby 2.3.1, you get an error because the 2 to the power of 80 doesn't fit inside a fixed num. It's a big num. The method I've defined is on fixed num, and therefore you get an error, where in Ruby 2.4 now, you're going, because it's an integer, it gets defined on the integer class, and it's consistent. So that's a change that was made to the integer class, or unifying the integer class from the two separate ones. Who uses pry in their projects? Of course. The only other thing for debugging would be print statement or put statements. Pry really helps from that point. Ruby 2.4, though, if you don't have pry in your project, all you need to do is just require IRB in a file, and then you can just run binding.irb instead of binding.pry. It works exactly the same way, but it drops you into an IRB shell. So if you don't want to have an extra gem dependency, that's built into your standard library now. Float round. Okay, now, as I say, this is quite an interesting one. First, we had a bug report in Ruby saying that there's an inconsistency between sprintf and float.round. Sprintf uses Gaussian rounding, which rounds to the nearest even, rounds halves to the nearest even. Float.round, by default, would round halves away from 0. Because of the disparity, they wanted to bring this back to, they just want to have a consistent rounding in floats. So, yeah. The motivation for Gaussian rounding is that it doesn't have any bias based on sign, so negatives won't round away from a 0. If you're in a negative space, stats won't get shifted away from the sign or towards the sign. It's supposed to be free of bias for that. That's why this is a preferred way in many cases. But, so in Ruby 2.4.0 Preview 3, this was actually the default way it was going to work. It didn't make it into the final release, thankfully. But if you had 12.5 and you rounded that, it would round towards the even number of 12 rather than up to 13, as you would have expected in Ruby 2.3. Thing is that as soon as this went into a preview, in the preview release, this bug popped up on the Rails bug tracker in GitHub. Suddenly we had tests failing in Rails on a minor version bump in Ruby, because the way of restoring that behavior would be to pass an option to the round method to round up instead of, or round halves up instead of using Gaussian rounding. The response was comical, which was then reported as another bug in Ruby by Rafael Franca, thankfully. And thankfully, well, what we then have to do, what they were going to have to do is then round halves up and down using, by passing these options in. So the options you do have now in Ruby 2.4 is that you can pass half even, half up, or halves down, which will determine your rounding directions. But the default is still the same as 2.3, which would be half up. Okay, this is where things get fun, turbo hashes. So CPUs have been becoming pretty good lately. the Haswell chips that are running probably most server data centers now have quite a few improvements to the level 1 caches. So Vladimir Makarov has done a really great job with the hash implementation in Ruby to take advantage of some of the speed improvements in L1 caching. So just for reference, if you're able to hit the L1 cache in a CPU, you should be able to hit that in 0.5 milliseconds. Hitting main memory takes 100 nanoseconds, 0.5 nanoseconds. Hitting main memory takes 100 nanoseconds. For reference, in half a nanosecond, light travels around about 15 centimeters. So that's a really fast time. So with no further ado, I want to just take a look at the speed differences that we can see in hashes now in Ruby 2.4. So again, using our splits over here, I'm going to run. Well, let's take a look at the code first. I've created a list of keys first. These are just hash keys that we're going to drop an item into a hash and measure the speed of writing all of these. There are 5 million of them in this file. Write 5 million keys and then read them out again and compare the speeds between Ruby 2.3 and Ruby 2.4. The way I'm doing that is just reading out of the file, writing the integer 1 into every key, and then reading it out again and then pushing out the results. So comparing that, let's just run that, hashes.rb, between the two. See quite a substantial difference between Ruby 2.4 and Ruby 2.3's hashes now. So that will affect you if you're running on Haswell CPUs. It means that you're going to be taking advantage of the hardware, and it's roughly about 40% faster thanks to this improvement that's been made. Okay. There's a great blog on Heroku about going into the details of what exactly that means and how Ruby's internal hashes work and what the difference between open addressing and closed addressing are that he's using to take advantage of this caching. Okay, array min and array max. Previously, if you called min or max on an array, it was actually calling back into the enumerable module. The proposal was then to bring in min and max methods on array itself instead of delegating through to enumerable. What that meant is that it would avoid creating new arrays in memory and put less GC pressure on that as well. So let's take a look at what that means to our performance as well. So let's look at the code that I've put together here first. I'm just taking an array from 1 to 10,000 and finding the maximum value in it 10,000 times, and then we'll just look at the benchmarks after that. A little bit of a difference. So in Ruby 2.3, we're using quite a lot more memory. It's taken up 4.5 seconds on my Mac over here. Ruby 2.4 was done in 0.2 of a second. So transparent change from your side, you don't need to do anything to take advantage of it, but if you're doing statistical stuff where min and max is important, working with Ruby 2.4 is now quite substantially faster. There have been quite a lot of performance-related improvements in Ruby 2.4. Okay. Another performance-related one is regex match. So this is a new method that's been added to regexes so that you can match strings, or you can match against strings without affecting any globals. Normally when you are using regexes in Ruby using the match operator, it would dump matches into global variables that you can read back on, and that's a remnant from the Perl influence of Ruby. And what match will then do is avoid any global state mutations and just give you a Boolean. The reason for the GIF I put in there is that because we think that regex is ever a good solution to something, it has something to do with Stockholm syndrome. Okay, so let's take a look at this again. So I've got here, again, I've got a regex Rubyfuza, and I've just got a match string of Rubyfuza. And I'm going to match it 10 million times. In Ruby 2.4, I'm going to use re.match, which would be the new method that's added. If it's not Ruby 2.4, I'm just going to use the equal squiggle match operator, and then we'll just look at what our results are. So again, we're about 6/10 of a second faster again. There's a lot less garbage collection pressure on that. Regex are faster. So if you want to just get a true or false match on that without affecting your global state, prefer using regex.match rather than the match operator. Just some other improvements that have been brought into Ruby 2.4 with this release, particularly for debugging. So threads previously would not report, you would not have a raise exception in your main thread if one of the background threads had raised. It would be silently ignored unless it was being waited on. Now with Ruby 2.4, you can mark a thread to report on exceptions. So, and that will also show the backtrace and the dependency that's being locked. If you hit a thread deadlock, you'll get the dependency listed and the backtrace of each deadlocked thread if you're doing asynchronous programming with Ruby. Some other resources that have been really useful in this. I mentioned the blog on Heroku. That's got a pretty good breakdown of particularly the changes to fixed num and the hashes. And a few of the other bits in there, but particularly those two are really good, well explained. The Ruby 2.4 release notes have links to all of the bug tracker, the bugs in the bug tracker of the features that have been changed or added. It's really good to just go through those and be current on what's been happening in Ruby lately. Thanks. My name's Kevin McKelvin. I'm at Resource Guru. If you're interested in working remotely, please come have a chat to me. We're hiring. And that's it. Any questions? Not in production. It's on staging. Deprecation warnings everywhere. Yeah? I've noticed the boot up time seems quicker. We haven't done serious performance tests on it, though, to really have an answer on that. Yeah. But it's definitely noticeable when you're doing specific performance benchmarks on regexes and arrays and things like that. So if you're relying on that, you'll definitely notice the difference, especially if you're on a Haswell CPU with hashes as well. Any further questions? No hands? Thank you for your attention.